In this tutorial, we're going to talk about geometric probability with area. And the probability that we're going to talk about in general is the probability of a certain event, and it will be equal to the favorable outcome divided by the possible outcomes. This notation right here, this capital P, simply represents the probability, and inside the parentheses is what we want. It's what's happening. So we could find the probability of a particular area, of a particular dice roll, etc. When we talk about favorable outcome divided by possible outcomes in terms of area, the favorable outcome is what we're going to be looking for. So the area specifically that we need. And the possible outcome is the possible area. So it's like the total area of your entire figure. And the best way to do this is by an example. So let's go ahead and start that. So here's our first problem. We're going to have a square that's 12 by 12 inches, and we're going to have a green circle somewhere inside of it. And the question is, what is the probability that you blindly touch the green circle having a radius of 2 inches? In other words, if this 12 by 12 piece of paper, let's say, is in front of you and you close your eyes and you put your finger on it, what's the probability that your finger lands in the green circle? So we have to first identify what we're looking for, and again, we're trying to find the probability that the green circle out of the entire square. Okay, it's important to know the radius of the circle, otherwise we cannot determine the area. So in the circle, I'm going to draw the radius, and it has a radius of 2 inches. And what we're going to do is we have to first of all determine the favorable outcome. In this case, the favorable outcome is the area of the circle. And we know how to find the area of a circle. Its area equals pi r squared. So we're going to go ahead and set that equation up. So the area of the circle is equal to pi times the radius, which is 2, squared, which ultimately will give us an area of 4 pi inches squared. So now we have to take a look at the possible outcomes. Well, the possible outcome is the entire area in which this circle is lying in, which in this case happens to be the square. So what we're going to do for the possible outcome is find the area of the square. And how do we determine the area of a square? It's simply side squared, because each side is congruent to the other. So the area of the square is going to be 12 squared, which we know to be 144. And of course, this is square inches. So now we just have to plug these numbers into our formula and divide them out. So in the entirety of this formula, I'm going to have the probability of the green circle equal to the area of the circle, which was 4 pi, divided by the possible area, the area of the square, which is 144. And altogether, since I'm running out of room, I'm sorry I have to do this, but I'm going to put the answer to this inside the square because it's my only blank space right now. But the answer is going to be 0.087. Now, if you guys think about this as a percent, remember that we would have to move our decimal 2 places to the right. So if I do that, then this becomes an 8.7% chance that you're going to put your finger in that green circle. So one other area of concern here is, what if your question asks that you leave your answer in terms of pi? So I want you to redirect your attention to the bottom right hand part of the screen where I have 4 pi divided by 144. If you have to leave your answer in terms of pi, the only thing that you need to do is reduce the numeric part here, which is 4 over 144, which both are reducible by 4. They both have a factor of 4. So that fraction now becomes 1 over 36 times pi, which you can then finally write it as pi over 36. So either answer is absolutely fine. It just depends on what your question is asking for as far as your answer is concerned. Let's go ahead and take a look at a couple more examples. So here we go. Just by appearance, find the probability that a dart would hit the shaded area. So this is if we don't even know what the area might be. We're not given radius, we're not given any dimension of any kind. This is just pure estimation. So in the first example, we have a green circle, and it just says that that shaded part is 60 degrees. So what you have to be aware of is how big a real circle has as far as degrees, and we all know that in a circle that it contains a total of 360 degrees. So as long as I know that that shaded region has a certain degree measure, I can do this very easily. So the desired area, the desired outcome is 60 degrees, and the total area or degree measure is 360 degrees. So we just simply have to use our calculators here to determine this, and what we get is 1/6. So that would be my probability for that, just based off of the information given. In the other example, we are given a regular hexagon. Remember that a regular figure of any kind has all congruent sides. So in this case, they have one shaded triangular part here. Okay, so think about how many triangles would fit in this particular figure. If it has 6 sides, then I'm going to have 6 slices. So that would be 1, the shaded figure would be 1. Here's 2, 3, 4, and then 5 and 6. So just by visually looking at this, that area takes up 1/6 of the entire area. So just by visual aid alone, I know that my possible area probability is also 1/6. Okay, here's example 3. We're going to determine the probability of a dart landing in the shaded region. And in this case, the shaded region is going to be the inside of these mini circles. And we are going to say that all 3 of those circles are congruent. So the area of one of them would represent the area of all 3. So first of all, we need to determine exactly what our probability is talking about. And we want the probability of the circles, so the area of the circles, like so, and that's going to be equal to the area of the circle. So this is the symbol for a circle, the area of a circle divided by what? So in this entire figure, what would the total area of this enclosed area be? And that looks like it's going to be that larger square. Granted, it looks like a rectangle, but we're going to assume it's a square. So we're going to determine the area of the square. Okay, so those little areas out of all of the area. So to do this, we need to find the area of each circle. So the area of this circle is going to be pi r squared, and I know that my radius is 1 centimeter. So that's just going to be 1 pi, or just pi. Well, how many of these do I have? I've got 3 of them. This one has an area of pi as well, and so does this. So how many pi's do I have altogether? I have 3. So this is going to become 3 pi. That's the area of the circles. And now we have to determine the area of the square. And the area of the square is side squared, or length times width, which is 8 times 8, and we get 64. So what we're going to do is we're going to assume that this particular question is going to ask for the total area as a decimal without pi. So in my calculator, I'm going to do 3 times pi divided by 64, and I get a total of 0.147. Oops, that's not a 7. Hang on. There we go. So if we talk about this in terms of percentage, we move our decimal place over 2 times, and I would get 14.7% chance of landing in a circle. Now, please take into consideration that although that's a very small percentage, my shape, my figure, is not drawn to scale. That's not a very big percentage. That's a pretty small probability that we're going to land in that area. But that's how we do this. This is your geometric probability. And that will conclude this tutorial.